Welcome to this video dedicated to discussing architectural electrical circuits in our modern world. Electricity is an integral part of our daily lives, especially when it comes to buildings and architectural designs. Architectural electrical circuits are the beating heart that ensures the safe and efficient flow of energy within homes, offices and buildings in general. In this video, we will provide a brief introduction to what architectural circuits are, their importance in modern construction, and the basic elements that comprise these electrical circuits in homes. We will also cover the fundamentals of planning and design for energy efficiency and electrical safety inside homes. This video will be your primary guide to understanding this vital field in a simple and clear way. Let's take the first step in the journey of discovering the world of electricity within building. Don't forget to subscribe to the channel and hit the bell icon for more informative videos. Let's get started. What is a differential circuit breaker? A differential circuit breaker is an electrical device used to protect people and equipment from the dangers of electric current resulting from current leakage or electrical contact. It is an essential part of electrical protection systems in homes, factories and commercial buildings. First, let's see how the differential circuit breaker works. The differential circuit breaker continuously monitors the electric current flowing in and out of the electrical circuit. The operating principle is to monitor the balance between the incoming and outgoing current. The current entering the device or electrical circuit is measured through the phase wire, known as phase in French. The current exiting the device or circuit is measured through the neutral wire, known as neutre in French. The circuit breaker detects the difference in leakage current. Under normal conditions, the incoming current is equal to the outgoing current. If current leakage occurs, for example, due to damaged wire insulation or human contact with the electrical circuit, a difference between the two currents appears. The circuit breaker disconnects the current in case of danger when the difference exceeds a specific value, usually 30 mA for personal safety. Cutting power quickly is crucial. It protects people from electric shocks due to current leaks. It also safeguards equipment and reduces fire risks from leaks or insulation damage. Compliance with safety standards is essential in modern electrical systems. Here's a practical example. If the input current is 10 amps and the output is 9.97 amps, the difference is 0.03 amps or 30 milliamps. This indicates a leak. In this case, the circuit breaker immediately cuts power to protect people and property. Now we'll look at how to connect the differential breaker. As you can see in this image, we have here this blue wire, which is the phase or phase in French. We have this blue wire here for the neutral. As you can see, they're entering this differential breaker, and then we see here in the outputs. The differential breaker, as you can see in this image, has the neutral going to this common point, then it's distributed among the rooms and electrical outlets.
After that, we have an output for the phase. As you can see, it goes to this circuit breaker or these single pole breakers or single phase breakers. As you can see, there's also a common point between them. Then we'll see the outputs in this location. So this is how to connect the breaker. We just discussed the main circuit breaker in the electrical panel. Now let's talk about sub-circuit breakers. These are key components in the distribution panel that distribute power to various loads in the building, like lighting and appliances. Their main job is to protect wires and devices from overcurrent or short circuits. They also divide the electrical load, allowing safe and organized power distribution throughout the building. Easy maintenance is another benefit, allowing isolation of specific circuits for repairs without affecting others. As for types, thermal magnetic breakers are commonly used to protect circuits. Excess current protection is available in various amperage ratings such as 32, 16, 10 and 6 amps. There are different types of circuit breakers that provide protection from both current leakage and overcurrent. They're used in areas requiring extra safety like kitchens and bathrooms. As mentioned earlier, we have main and branch circuit breakers for power distribution to various loads. We also have a common point for neutral wires. Let's continue our discussion. Now we're going to discuss a very important part in the electric distribution board, which is the ground line. If you don't see the grounding line, you'll notice it's yellow, usually yellow and green. The grounding line is one of the most significant elements in the electric board and is considered essential to electrical safety. Its main function is to provide a safe route to direct any excess current or surge resulting from electrical faults like lightning or electrical theft towards the ground. The grounding line's role in the electric board is to protect people, to prevent the occurrence of electrical shocks when touching metal appliances connected to two electrical circuits. It protects equipment and decreases the risk of damage due to excess current or unexpected loads. Thirdly, it provides a low resistance path and makes it easier to divert the surge current towards the ground to prevent an increase in voltage in the system. Fourthly, it reduces the risk of fires by minimizing the chances of electrical sparks that could start fires. Pardon the interruption, components of the grounding line system in the electric distribution board include a grounding connection tape, a metal tape inside the board where all the ground wires are connected. Then, what we see afterwards is the connection point. As you can see, all the rooms are connected to this spot, which means in every room of this house we will find a grounding line connected to the outlets that power devices like air conditioners or any electrical appliances. We just discussed the switchboard. Now let's talk about the electrical junction box. The junction box is always connected to the electrical switchboard, as you can see. The junction box is a key component in electrical systems used for connecting electrical wires at a single point safely and neatly. It protects the wires and allows access for maintenance or future modifications. The main functions of a junction box are to join wires coming from various sources like circuit breakers, switches, lights, outlets, etc. Secondly, it shields electrical connections from environmental factors like dust and physical damage. Third, it enables easy maintenance by providing clear access points to change or repair wire connections. Lastly, it ensures safety by preventing electrical sparks or shocks from exposed wires. There are several types of junction boxes. One is the surface mount box that is installed on walls or ceilings, used where wiring can't be hidden, like factories or garages. Hidden junction boxes are installed in walls or ceilings for concealed wiring in buildings or homes. Weather-resistant boxes are used outdoors or in damp areas, made of waterproof materials. Junction box components, we have a lid to keep out dust and moisture, 2 entry holes for cables and wires, 3 fastening keys to secure wires and grounds, and connection terminals for safe, organized wiring. How to wire a junction box. Prep wires. Strip ends to appropriate length for connection. Two, insert wires into box. 3, join wires using electrical connectors or terminals. Arrange wires neatly in box to prevent interference or sparks. 4, close box. Secure lid tightly to ensure protection. Follow safety standards when using junction boxes. use appropriate size. Ensure box has enough space for all connections. Choose suitable box for environment. Use weather-resistant boxes outdoors or in damp areas. Avoid exposed connections. Junction boxes are important in electrical systems. They maintain aesthetics by hiding wiring in walls, ensure safe power distribution, and facilitate future system modifications or expansions. We have now discussed the connection method and the elements of the key distribution panel, as well as the branching box and its function. We will also discuss the method of connecting a lamp for simple lighting through this simple lighting switch. We will see the connection method coming from the key distribution panel, then we will see the connection from the panel to the branching box, then to the switch, and then finally to the lamp. So the first thing, we start from the key distribution panel. As we discussed at the beginning of this episode, if we have a phase or the wire came out from the differential cut, then afterwards we got it to the sub-breakers. For example, let's take this branch segment number 1. If we connect with it, phase number 1, that's, as you can see in the color, in red. If this wire with the other wire, which in blue, if we connect them with the branch box, if you don't notice in this picture, you will see here the wire in blue and the other wire also in blue, and the other one in red. These are if we get to them coming from the electrical switchboard to the joy box. Now we will open this key. For simple lighting, as you can see in this picture, we see the 2 yellow wires. These 2 wires came from the junction box. So let's take a closer look at them from the junction box. As you can see in this picture, these are the 2 yellow wires. Additionally, 2 yellow wires are connected from the lamp to the junction box. So here we find 6 different wires. The connection method is as follows. The live and neutral wires come from the distribution box to the switches. Then we find 2 more wires from the electrical switch and 2 other wires from the lamp. We directly connect the neutral wire to the lamp's neutral wire, and then we connect the live wire to the live wire from the distribution box. We connect the switch wires together, leaving us with 2 wires, one from the switch and one from the lamp. Finally, we connect these 2 wires together. This is how you wire simple room lighting from the switchboard to the junction box and then to the room with the lamp, as you can see. If now we talked about the simple way to connect the lighting to room number 1, we said it will be connected with this subplot number 1. If we give you information also, so all the rooms, for example, room number 1 is made up of 2 pieces, excuse me, sub, if for example it is a cutter number 1, and a number cutter 2 for room number 1. So why do we use cutter number 1 and cutter number 2 for room number? If the cutter number 1, if we explain, we said we reached it with the simple lighting that works with it. This room, if now we are talking about subsection number 2 for room number 1, if the piece is sub number 1, if it is connected with electrical outlets, as I see. You notice in this picture if these wires are connected through the electrical switchboard. So now we come to explain the method of connection. These wires that are connected to the electrical outlet, if the electrical outlet is always connected to 3 different wires, so now I don't see. You notice we find it here. 3 different wires, as you can notice in this picture. If we have the wire in red from here, and we have the wire in black from here, from point number 2, and we have wire number 3 from point 3. If we have a red wire representing the phase, which in French is called phase, and point 2 in black. Represents the neutral or neutre in French. Then we have a yellow ground wire. As you can see in this picture, if we go to the distribution panel to check these wires, where do they come from? These wires don't go through the junction box. They're connected directly from the distribution panel. They come with the ground and then go to the electrical outlet. Wire number 1 comes from the sub-circuit 2 for room 1, which is the phase or line 1. Then we connect wire number 2, which is neutral or neutre in black, from the common point . We connected it through this circuit breaker or differential switch. As you can see, we connected it to this common point for the phase and neutral. Then we have the ground wire or terre in French. This is our ground wire. It came from outside from the main panel, then came here, as you can see. It came to this point where we have a common connection. Then we branched out from this point, creating wire number 3, which went through this conduit or gain in French to this outlet. As for the wire, it means the wire should always be 2.5 mm when the electrical load is very large. For example, if we want to power a mixer or small appliances that don't consume a lot of electricity, if we use a 2.5 mm wire, that should be sufficient. This is regarding the outlets that don't consume a lot of electricity. Now, if we talk about room number 1, let's go back to the explanation. If we say there is circuit breaker number 1, dedicated to lighting and circuit breaker number 2, we said is dedicated to the electrical outlets, which are made up of 3 wires. One is the live wire, number 2 is neutral, and number 3 is the ground wire or earth wire in French. So this is for room number 1, or for example in the kitchen, if you might ask this question, how do we manage or connect from the electrical switchboard distribution box to outlet number 1? If we say we have, for example, outlet number 2 and outlet number 3, etc. in this room or in the kitchen at home, how do we manage or connect the other outlets? We said that we come from the distribution board with only 3 wires. So how do we do it? So if we take 3 wires from point 1, out of the 3 wires we got from the electrical switchboard to this outlet number 1, then we take the other 3 wires and go to outlet number 2, then 3 come here, we install them here, connecting wires, making a common point between the wire from the switchboard and the wire from this outlet going to outlet 2, then the same for outlet 3. This is how to connect electrical outlets in room 1. Now we talked about room number 1. Now we're going to talk about room number 2. This room consists of 3 different subswitches. Druck asked this question, you might say why this room consists of 3 electrical switches or 3 subswitches. If you know, we will answer you. So the first thing we go and see, the number 1 switch, if one opens it, is used for simple lighting, as you can see in this picture. And the number 2 switch is used for electrical outlets. As I mentioned at the beginning of the episode, I said the phase, neutral and ground come to take number 1, and then we take from take number 1 to take number 2, and go from take number 2 to take number 3. This is regarding the socket. Druck, we go to the question, I told you why we use 3 different electrical outlets. Now we said 1 we use for simple lighting to fix this room, and the other we used to connect it with the simple sockets. I always take, key number 3, we use it with the air conditioner, as you can see in this picture, and our cable or wire, we don't use it with 2.5 mm, right? We use it with 4.5, with a 1/4 millimeter walking with 2.5 mm. Why? Because the French language or the air conditioner consumes electricity a lot, so I used the 6-duobit cable in exchange for, or instead of the sockets that we use, for example, to charge the mobile phones, and also for the TV. If this is the choice, we use them for the TV ports and do not charge with it. Transport phones? No, so we use 2.5 mm and is enough, but with regard to air conditioners, we must use la section de cable. It must be 2.5 mm, you may ask. You say, how can these wires be gone? So they reached room number 2. So with regard to lighting, if we came here, he won, and the nater we said means the key.
Number 2 is used for room 2. If this goes to the junction box with the neutral and live wires, they go to the branch box. As we explained before, the method of connecting simple room lighting, these go to the junction box, then we're left with the phase and neutral wires coming from the main switch. We have phase 1 and phase 2 going to room 2, which goes to the simple 2.5A sockets. If not going to the junction box, they go straight to the simple electrical outlets. Then we have sub-circuit breaker number 4, or number 5, sorry, which always goes to room 1. We use this for the air conditioner. It also goes directly. If we use the wire, it comes out of the sub switch, which is the phase or phase in French. We also bring the neutral from the common point and get line 3 from the ground, or terre in French. If they all go together, then they go to the outlet that powers the air conditioner. Now I'm going to talk about the living room, which in French is salon. The living room is always large, consisting of 2 different lamps. We don't go for simple lighting here, no, we use double lighting. In this living room, we also have to install a specific outlet for the air conditioner. Also, I didn't tell you, we use dual lighting, which is like this. If the switch for double lighting is on, these lamps are turned on. For instance, if you need lamp number 1, we turn on the circuits of lamp number 1. I don't think you noticed. If you need lamp number 2, we turn on the circuits of lamp number 2. Regarding the delivery method, we always exit. We always take from 3 different keys. If it's key number 1, we take from it phase number 1 of this indicator, and we also take the neutral or common from the common point. I didn't tell you where these go. They go to the box of joy. In this way, if they reach this branching box, and then what happens through this branching box is we take 3 wires. They go to the switches dedicated to double lighting, which is this. If we draw 3 different wires, if wire number 1 is phase and wire number 2, it goes to lamp number 1, and wire number 3 goes to lamp number 2. If this it is the method of delivery. And then what happens through the electric branching box, we also take neutral. I didn't tell you who we take from the electrical switchboard 3. Excuse me, 2 different wires. If one is the phase of the other is neutral. If we take the phase, he goes to the common point in the key to double lighting. I didn't tell you to be connected or to be de sortie in French. If this de sortie, de sorto, they go to the lamps directly or they go back to the box of joy. Then after that, through this box branching is delivered this do to a go to. The lamps are here, and then we have arrived through the neutral switchboard to this is the box of branching through this neutral. We connect it to 2 other wires for the lamps. This one for the lamp number 1 and wire number 2 go to lamp number 2. This is regarding lighting.
Either regarding the electrical outlets that are always sitting, we take three wires. The first thing, we allocate them to the outlet that we use to charge the phones and also to turn on the TV or feeding the TV and the radio and so on. I mean the devices that we need in these living rooms. And we also take number two, we use la section du câble, in French for carry, depending on the rack that, according to the holder of your air conditioner, go to the socket designated for the air conditioner is usually here, I mean under the scaffold. A little bit for 40 or 50 centimeters regarding the simple sockets that I told you. I mean, they are intended for charging phones that are 40 centimes or above the ground, above the ground. Now, let's discuss the hallway lighting. Typically, a hallway has 2, 3 or 4 different lamps. For instance, this hallway, as you can see in the image, has 3 lamps. There's lamp number 1, lamp number 2 here, and lamp number 3 over there. As you observe in this picture, we can control these lamps from multiple locations or 2 different spots. Depending on the location, if we use 2 switches here, switch 1 would be here and switch 2 would be there. Notice in this image, if we use a go and return light, or va-et-vient in French, the wiring method for this type of lighting always involves 2 switches. These switches always have 3 different wires inside. As you can see here, it's made up of 3 different wires. We have 2 yellow wires, as you can observe in this picture. Let's clarify the image. We have 3 wires, 1 red and 2 yellow. Now let's look at switch number 2. It's the same thing, we also find 3 different wires in the same colours. Here we have 2 yellow wires and 1 black wire. If you notice, we have a junction box here. Under this junction box we have switch number 1. If we brought the phase through this, or connected to the phase in French through this junction box, we came to this switch, then we came out with the 2 yellow wires. They also return to this junction box. So through this junction box we form 2 wires and 1 more. We took them to branch box number 2. Where do we find it? It's right here. Through this branch box we brought 3 wires here, as you can see in this picture. If these are the 3 wires, what are we doing? We have 2 wires connected to switch 1. What about wire number 3? It goes to the lamp. We brought the live wire or phase from point 1 or switch 1. Here's the output, or the rotor goes to the 3 lamps. They're connected in parallel or en parallel in French. Now if we brought the live wire to lamp 1, then to lamp 2, and finally to lamp 3, we also connected the neutral wire. That's how we wire corridor lighting, or couloir in French. What else do we find in the hallway, or couloir in French? We also find the doorbell. As you can see in this image, how can we connect this bell? We see the button outside the door, so the connection method is as follows. We install the phase or live wire from junction box number 1. If it goes to this button or pressure switch, it goes to point number 1 here. Then wire number 2 exits, returns to the junction box, and then goes to this bell. This bell has 2 connection points for different wires. We connect the wire from point 1, and wire number 2 comes from the junction box's neutral. That's how to connect the bell. Now let's see how to connect a bathroom, or la douche in French. You'll notice the key is here and it has its own dedicated lamp. In this picture, if we have simple lighting, we can connect 2 wires that go to this extractor fan, which turns the lamp on and off. We can switch off this extractor fan, which is used to ventilate the bathroom. We also need to run 2 wires to the light switch to control the lighting. This bathroom always has a dedicated switch. The wires run from the electrical panel with live and neutral wires going to the junction box located in this area. The wires then split, with one pair going to the switch and the other to the lamp. If we want to add a washing machine in this bathroom, it's best to use 4mm wire since it draws a lot of power. And that's how you wire up a bathroom. Now I've covered almost all the home circuits. Let's talk about the balcony, or balcon in French. Typically, balconies have a simple lighting circuit. The setup depends on your specific needs. First, we always have a switch or circuit breaker for the house balcony. Usually we need 2 for power cuts, but I'll explain why we only need 1 here. We we use it for basic lighting to illuminate the balcony. Let's take a look at why I mentioned needing 2 electrical switches. This is my house balcony, and I'll explain based on specific needs. As you can see, I've installed a water tank here and a pump nearby. Consequently, I need an electrical outlet. This outlet should be in a dry area, away from the water tank. We also use extension cables or wires which must be 4 square millimeters thick. This depends on your pump size. Larger pumps require more electrical current or a higher load. So we need 4 mm wire. For a small pump, you can use 2.5 mm wire. This is for the electrical outlet. We need a separate circuit breaker just for this pump. We also have simple lighting for the balcony, or balcon in French. If you notice, this basic circuit is currently disabled. Now, as we finish explaining home electrical circuits, we'll discuss types of electrical faults in houses and how to explain this circuit. Let me explain the wiring method. First, we take the phase wire, or phase in French, from one of these electrical switches. This phase wire then goes to the junction box and from there to the lamp. We also connect the neutral wire, or neutre in French, to the junction box. From the junction box, it goes to the lamp. It's always necessary to connect a ground wire. The phase wire comes from one of these switches, and we also have the neutral wire. We connect them directly to this electrical outlet on the balcony, which is dedicated for the pump. That's how we wire the balcony. After reviewing all home electrical circuits, I'll now discuss how to identify common electrical faults in the house and important safety measures you can take to deal with them. So, first we'll learn about types of electrical faults that occur in home circuits. The first fault is loss of electrical insulation, or défaut d'isolement in French. Second, short circuit or court circuit in the home. Third, overload or surcharge in French. Fourth, faulty appliances, meaning the electrical device itself is malfunctioning. Fifth, phase wire touching the wall, which we can identify as insulation loss or défaut d'isolement. Sixth, frayed wires. Now let's talk about the first type of electrical fault, which is insulation loss in electrical wires.
For example, in this washing machine, the wire might touch the cover. This washing machine issue can cause problems. Similarly, in refrigerators or any appliance in the house with this fault. Now let's see how we can solve this problem and identify it. Before we look at this device or another one, let's discuss how to identify this issue. The way to detect this problem is through a differential circuit breaker, or disjoncteur différentiel in French. This tells us if there's an issue with electrical wire insulation. So what happens when a wire touches the cover? With this differential circuit breaker, what occurs if we have continuity or current? For example, our washing machine consumes 10 amps. When there's contact with the machine's cover, it still consumes 10 amps. But if this contact happens and it draws 11 amps from the phase, for instance, when we touch the washing machine, if the wire contacts the outer cover, what happens? Say 1 amp goes through the cover and then to the ground wire. What occurs? There's a difference between input and output. So what happens if consumption is 10 amps, but 10 amps return to the differential circuit breaker? Then we have a difference between input and output. If 11 amps go out and 10 return, the differential circuit breaker trips or shuts off. Thus, we can identify this issue. We say there's a difference between the outgoing and incoming amperage. From this situation, we conclude there's a loss in wire insulation. So this is the first type, meaning this differential breaker indicates a problem with insulation loss in household appliance wiring. So this is about the first issue, or how to detect electrical wire insulation loss. For electrical appliances. Now let's consider what happens when there's a wiring insulation fault. This could trigger the circuit breaker or differential cutoff switch. The question is, how do we pinpoint this fault? Is it in the washer, fridge, or another appliance? That's why I stress the importance of using sub-circuit breakers. As I mentioned earlier when explaining home electrical circuits, each room, kitchen and bathroom typically has 2 switches, one for outlets and one for lighting. So if we consider that each room has a sub-breaker for outlets, we can identify which device is connected to which circuit. For instance, circuit 1 might be the fridge, 2 another appliance, and so on for each room. Now, here's how we determine the issue. First, we need to turn off all the individual circuit breakers in the electrical distribution panel. Then we'll switch off the main differential circuit breaker. After that, we'll start turning the breakers back on one by one. For example, we'll switch on breaker number 1, which stays on. Then we'll turn on breaker number 2, which also remains on. When we get to breaker number 3, which is connected to the kitchen fridge, and turn it on, the main differential breaker trips. This indicates that the issue is with the circuit connected to breaker number 3. For electricity issues, if we can identify our specific problem, let's say it's in circuit 3. When we turn on circuit 3, the differential circuit breaker trips. In this case, we'd say the problem is in room 3. We go there and find, for example, a fridge or maybe a faulty pump. Let's say switch 3 is connected to this pump. When I flip switch 3, the problem occurred. So we say the issue is here. The second step we take to pinpoint the problem is to ask, is the pump really the issue? To check, we unplug the pump from the outlet. Then, if we go back to circuit 3, which might be for the balcony or parco in French, and disconnect all devices plugged into that circuit, we can determine if it's the appliances or a wiring issue. We repeat the process. Turn off all switches, then turn on the main breaker, then switch on circuit 1. No problem. Switch on circuit 2, problem occurs. This way, we've identified the faulty device. That's how we troubleshoot electrical issues. So now we talked about malfunction number 1, which is the loss of the insulator. So maybe now you say, why is it lead disconnect is off? Now this means, for example, I have a problem in circuit number 3 in electricity leakage. Why does this fall before it falls? If this means bring us or lead us to the type malfunction number 2, which is a palace in the electrical circuit. So this we go to type number 2, electrical faults, which is the electrical circuit palace if this junctor or these sub-circuit breakers are used for the electrical circuit palace. So this doesn't fall when there is electrical insulation, when Devo Desomoa, or in the loss of the insulator. I mean, for example, you graduate 10 and come back to 5 because he is an individual cutter. So now we go to the method of determination, which is malfunction 2. The type of malfunction, which is the electrical circuit palace in this case. Now, how can we know? But it was the other palace when the electricity will work at home normally. And then after that, this disjunctor fell number 2, for example, or number 3, for example. This alone, we found it fell alone when we go back. I mean, it falls again. If this, we can say, I mean, we determine the type of malfunction, which is a palace in the electrical circuit. And this malfunction, for example, in room number 2 or in the balcony of the house, if this means a location, by the way, this problem happened to me at home or in the balcony in French, if this problem happened to me in the palace of the electrical circuit, what is the reason for this harmful palace? If the reason is that there was a burn in these wires, they forgot to get a little closer.
a burn happened in this electrical wire that he saw in the lamp load burned. This is the lamp load, and also, I mean, this problem happened to me in the key distribution board. If I can determine this problem from, I mean, the key distribution board, when I knock down this sub key dedicated to descend it down, excuse me, to the balcony of the house, or balco in French. So this is the way to determine the electrical circuit palace. I mean, we identified the location of this problem, we said, in the balcony of the house. Why? How we identified it? Because this key is for the house. First of all, we specified our malfunction, and number two, I mean, I have a problem in the balcony of the house, only if, I mean, this malfunction is in the balcony of the house, only, I mean, the light will not go to the house or the electricity floor in the house. So this is the benefit in the electrical sub-switches, in the electrical switchboard, in the electrical switchboard in the house. Now you might ask this question, tell us, sir, I mean, Druk, tell us, yes, you have a problem in the circus of the lighting or in the lighting circuit. If something easy is apparent, yes, the problem is in the lamp or in the electrical switch. I mean, this is right. If we have a problem in the electric bag in this room, how can we solve this problem if it is something very easy? So the first thing, we go to this room, we greet all the electrical plugs, we greet all the electrical plugs in this way. I mean, all the sockets that it was tied to this socket. If we greet all these sockets, we go back to our switchboard, and then we look at this deconnector. If this means the subkey, we say it means a problem in electrical appliances. If this switch is not in the electrical appliances, if this switch is not in the electrical socket, we say the problem is in the electrical socket. So this is how to determine the circuit palace. Let's move on to malfunction number 3. This issue, determined by the sub-switch, is called an overload. What's an overload? It's when electrical current exceeds a wire or circuit's capacity, causing overheating. This poses a fire risk or equipment damage. In a short circuit, current flows through a zero resistance path. These sub-switches are thermomagnetic circuit breakers, activating when a short occurs. We have magnetic protection, and in case of overload, if the wires heat up, we also have thermal protection. So who can identify the type of fault? We mentioned error type 4, which is a device malfunction. It could be a touch in the cover or wires touching each other. If this happens, it might be inside the device. Sometimes, when there's a short circuit, this problem occurs. The circuit breaker or sub-switch detects this when there's an issue with wire insulation or contact with the outer cover.
This person is responsible for pinpointing the problem in this device, specifically the touch number 5, which affects the wall. This person is able to identify this issue. Please excuse any disturbance if this issue occurs at home. Please go ahead. Subsequently, we employ the method we discussed, starting by powering off all the sub-breakers and then turning them on one by one. For instance, when the key number 3 tripped, if we disconnected all electrical appliances connected to this particular outlet and the problem persists, then, as with the initial approach, we still have the issue. If this is the case where there's a phase touching the wall, there's also another type, related to frayed wires. Whenever we explore solutions to this issue, we usually find, for example, this indicator at the junction appears burned, and it's possible that this indicator won't function. Perhaps at one point, either in our devices or elsewhere in the house, the wire was frayed, resulting in overheating. Therefore, an attack or failure could occur. This explains the method for diagnosing faults. Thus, we advise, if you have any questions, please write to us in the comments section. We wish you God's protection.